today's GFG POTD, we have a problem, largest pair sum, and it is basically an easy level of problem. And as a problem given here, find the largest pair sum in an array of distinct integer. So basically, we have an array, as we can say in the example first here, like 12, 34, 10, 6, and 40. And here we have to return the largest pair sum in array of distinct integer. So as we can say here, what are the largest element in this particular array? So here we can get like 40, and the second largest element is like 34, which creates a pair. So we can say that here we know that the pairs are actually the combinations of two elements. So what we can do, how we can get the maximum largest pair sum in an array? Okay, so for that thing, what we can do, how we can get this particular element like 34 and 40 together, so that we can make a pair and take a sum of it and return our solution. So for that thing, what we can do, uh, we have to solve this problem with an expected time complexity of order of n and expected auxiliary space of order of 1. And here the topic tags are like, we can say that we can solve these things by using two pointers algorithm, array searching and sorting. Okay, like that. So how I am going to solve this problem? So my approach is really very simple. Here what I'm doing here, first of all, I'm going to sort this array. While sorting this, we get elements in like sorted manner, like this particular elements inside the array we get like 6, 10, 12, 34, and 40, by which we get the largest element as well as the second most largest element we can get together, by which we can make a pair and we can take the largest pair sum. Okay, so first of all, what we can do here, first of all, I can sort array dot begin and then array dot end. Now once I've sorted this array, I'm getting this particular array. Like if I'm talking about example 1, so I will get like here 6, then 10, then 12, then 34 and 40 and 40. Okay, so these are the 5 elements here. So we get here 34 and 40. Now we need to take a maximum sum. So for that thing, first of all, we have to get the maximum element in the array. So for that thing, we need to traverse it. Okay, so before that, I have to define like int max1. Let's say I define max1. Here I have to declare max1, and I have to initialize with array of 0. That means the first element, which is like 6. Now after that, what we can do, by 6 we actually comparing to rest all the elements inside the array, and we check which one is the maximum element in the array. So for that, we need to traverse it like for int I is equal to 1 and I is less than, we can say that array dot size and then I plus plus. Okay, while doing this thing, what we have to do here, we have to give the condition if array of 0, or we can say if max1, if array is greater than max1, then what we need to do, we need to store this element max1 is equal to array of I. Okay, here we need to compare all those elements. So here we have to also do, here we actually checking the condition. So if array of I is greater than maximum element, then we need to store that array inside the maximum element. And then after that, what we have to do, here we have to create a vector, okay, which basically stores the value. So here I'm saying that vector int, and here we have to take the sum of it. Okay, so here I have to say here sum. So simply what you can do here, I need to move out from this scope and take sum dot push back. And but before that, let me show you about the result. Let's say if I'm saying that return max 1, then what we will actually getting, while returning we get our output as 40. So that means we actually getting our maximum element. That means here we are actually getting maximum element. Okay, the first most largest element inside the array. Okay, now we can simply do what, we can simply return it in the vector. So here I've declared the vector by some variable. So here we can say that sum dot push back, and here we need to store what, here we need to store about maximum one element. Once we have like stored these things, now we need to follow the same steps to find the second most largest element in the array, which is like 34. So how we can get this element? By traversing from this position to this position. We have to like, we don't have to count this position so that we can get the second most largest element. Okay, so let me show you for, but before that here we have to also create let's say int max 2, which is equal to array of 0, because here we have to again do the same thing, that means comparing the first value with the rest of all elements inside the array. And here what we have to do, here we need to traverse it like for int I is equal to 1 and I is less than array dot size, and here we need to like traverse it through size minus 1, that means till 34 position. Once we actually traversing till 34, we actually are getting the maximum value, which is like 34. And then I plus plus, here we have to do the same thing, and here we have to say the same thing, that is array of I, if it is like greater than max 2. Then what we can do, here we need to do max 2 is equal to array of I. Now once we have done the same thing, what we have to do, again we have to push this particular result inside the vector, so sum plus push back, and here we have to do what, max 2. Okay, now once you have like taken all those two maximum values, that means the most largest element inside the array and the second most largest element in the array, now after that we need to take the sum of it. Okay, so again now we need to traverse inside the vector, so here we need to result, here we need to print the result. So what we can do here, here we have to like comment this thing, and now we need to traverse it like for int I is equal to 0, and here we need to traverse it, in this time we have to traverse it inside the vector, so you can see that in sum dot size, and then after that here we need to do what, I plus plus, and here we need to do one thing, that means here before that here we also define about add. Let's say if I'm defining int add is equal to 0, then here we need to what, add plus is equal to sum of I. Once you have like done this thing, we need to like return the result, which is like add. So here we need to simply return add. Let's try to compile and run. So its compilation is completed. Let's try to submit it. So it's submitted. So yeah, that's all for the today. Thanks for watching.